Hello everybody, I'm Dan. Welcome to my Java tutorial series. All of the source code for each video tutorial is located on my website at javascijava.com. Throughout my tutorials, I will teach you Java using just Notepad and the command prompt. This tutorial, I'm going to talk about the char data type. So I'm going to go ahead and pull up my website here, www.javascijava.com. We'll click on the Begin button, and I'm going to come down here to the char data type tutorial. So the char is a primitive data type, one of the few primitive data types that there is in Java. And this tutorial will explain what the char data type is. In Java, the char is a 16-bit Unicode character. Now that sounds kind of scary. You know, what is a 16-bit Unicode character? It sounds pretty cryptic. Unless you know already, then I'm going to do my best to explain what it is. And basically, every individual letter, number, and symbol on your screen, such as ABC, XYZ, 0, 1, 2, 3, pound sign, dollar sign, percent, is represented by a Unicode character. To understand what a Unicode character is, you will need to understand some key concepts of disk memory. This tutorial will provide a crash course about things like bits, unsigned bytes, binary, decimal, Ascii, and how they relate to Unicode characters. Okay, so the first thing I'll talk about is bits and the unsigned byte. Your hard drive, thumb drive, SD card are all examples of disk memory storage devices. Typically, each one has the memory capacity listed in megabytes, gigabytes, or terabytes. A bit is a single memory location that contains either a 1 or a 0. Now, there are 8 bits in a byte, and there are 16 bits in 2 bytes, which is what a Unicode character consists of. Let's imagine for a moment that we have an empty thumb drive. If we could peel it open like a giant scroll and look at the memory, we would see millions of zeros all lined up for as far as the eye can see. So what would a single byte look like? Well, it's basically 8 zeros. 8 little bits. On an empty one, it would be all this. Okay. So now we can talk about the binary numeric system. Everybody knows the decimal system. You can count from 1 to 100, then keep going on forever if you want to. With binary numbering, the numbers 1 and 0 are used to represent all real numbers. To figure out the decimal value of the binary representation, you will read the 1s and 0s from right to left. In a byte, the rightmost bit represents the decimal value of either 1 or 0. Okay? So decimal 0 is equal to 0. Decimal 1, we've got a 1 right here. And this 1 does not translate directly into 1. 1 indicates that it's the this particular little byte column here, its maximum value is 1. So the second rightmost bit represents a decimal value of either 2 or 0. So if we got a 1 here, this particular column maximum value can be 2. The third rightmost bit represents a decimal value of either 4 or 0. So you can see we've got 1, 2, 4, and then the next one represents a maximum value of either 8 or 0. Next one is either a 16 or a 0, 32 or 0, 64 or 0, 128 or 0. So hopefully you notice that the value of the bits keeps doubling as you move from right to left. Now we can build on this concept to create other numbers. We do this by adding up the bit columns. Let's create the number 3 by placing a 1 in both the first and second rightmost columns. We'll add up the max value of those 2 columns to produce the decimal equivalent of 3. Okay, so this is our 1 column, and that's indicating that 1 is it's full per se, and we've got a 1 in here indicating that the 2's column is full, so 1 plus 2 equals 3. Decimal 5 can be represented by adding up the first and third rightmost columns, okay? So this is the 1 column, the 2, and the 4 column, right? The 2 column is 0, so we don't count it. So we add up the 1 plus 4, and we get 5. Decimals 6 through 10 are represented as binary in these following lines. So we've got our 1's column, our 2's column, and our 4's column. 2 plus 4, 6. 7 is represented by 1 plus 2 plus 4 equals 7. Now our 8's column, of course, is represented nothing in this one, nothing in the 2's, nothing in the 4's, and we've got a 1 in the 8, so that's decimal 8. We've got a 1 in the 1, nothing in the 2, nothing in the 4. We got a 1 in the 8, so 8 plus 1, 9. In the tens column, for 10, decimal 10, what we've got is nothing in the 1. We've got a 1 in the 2's column, nothing in the 4's column, and a 1 in the 8's column. So 8 plus 2 equals 10. The largest decimal value a single unsigned byte can hold is 255, and that's all solid ones. Okay, let's talk about the Ascii table. The Ascii stands for American Standard Code for Information Interchange. Simply put, every character such as ABC, XYZ, 0, 1, 2, 3, pound, dollar, percent can be represented as a decimal or binary value. Think of Ascii as the predecessor to Unicode because Ascii only represents the English alphabet and the numbering system. I'll use the uppercase A to explain how Ascii works. The letter A is represented by decimal 65. The binary equivalent of decimal 65 is this right here because, of course, we've got a 1 in the 1's column, then we got 2, 4, 6, 8, 2, 4, 8, 16, 32, 64. So we got a 1 in the 64's column plus the 1 in the 1 equals 65, right? That translates to the uppercase A in the Ascii chart. Now, if the only thing on your drive was the letter A, you would simply see the binary representation, binary being a whole entire bit here, right? We've got our 1 bit here, followed by billions of zeros, right? So a decimal 66, which is the next, which is B, right after that, is represented right here, right? You got your 64 column right here, plus your 2 column, 66, uppercase B. 67, right, is the uppercase C. 64 plus 2 plus 1, 67, pretty simple. Hopefully you're starting to get it. And then just skip down here the decimal 84, which is represented as the binary in that, which is uppercase T. So now if the only thing on your thumb drive was the word cat, you would simply see this. You would see the letter C, right? Right there. And then you would see the letter A, which is the next 8 bits. Right there, right? And then you would see the letter T. So this would spell out cat on the memory, followed by, billions of zeros. Now keep in mind, I am really oversimplifying things. There is way more to memory storage than I can even talk about in this tutorial. There are things way beyond the scope of this tutorial, like file allocation tables, head sectors, etc. I have provided an Ascii printable characters table at the bottom of this page. So if we scroll down here, here's all the Ascii printable characters, which are basically just like the characters on your keyboard. There's more to it than the Ascii table contains more characters than what's listed here, but these are the printable ones there. So we can scroll down here and you can see like the digits, the uppercase letters, the lowercase letters, and their corresponding decimal and binary values there for each one of those. And let's go ahead and scroll back up. I promise we're getting close to where we can do some code here. Now we're going to talk about 16-bit Unicode and what this has all been building up for. So, early computing relied entirely on the Ascii standard English only. As computer technology advanced, it became apparent that the rest of the world's languages would need to be able to communicate using computers too. How could someone in China use a computer if they didn't know how to read and write English? Well, Unicode was born in 1987 to address that very issue. Instead of using just a single byte to represent a character, they decided to use 2 bytes to represent each character. If you recall from the binary numbering system above, each time you extend a bit to the left, the number represented doubles. So the bit column values would look like this, right? 1, 2, 4, 8, 16, 32, 64, 128. That's where it ended before at a single byte. Now we move on to the next 8 bits, 256, 512, 1024, 2048, 4096, 8192, 16384, 32768. That is a lot of characters that Java can support using the Unicode standard. So, the original Ascii values were kept the same, so you can just tack on an extra 8 zeros to the beginning of each binary representation. So in Unicode, the letter A is represented by the decimal 65 still, but then the binary Unicode version of it tacks on an extra 8 digits, right? So this is all pretty much the same, except, you know, if the only thing on your thumb drive was the letter A, you would see this followed by billions of zeros. So we've got our oscillator B and our C and our D. So if we were to have just the word capped on our thumb drive, you would see it represented as this right here. So as you can see, the uppercase C right here is now this Unicode character here, takes up 2 bytes now. The letter A represented right here, and the letter T represented here, but followed by billions of zeros. Okay, so that's what a 16-bit Unicode character essentially is. So now let's talk about one last little thing, and we'll go ahead and write some code. So a Java character literal is simply a single character enclosed in single quotes. Okay, single quote C, single quote. So these are all examples of character literals here. And now we're ready to go ahead and get started. Let's scroll down here to our first exercise, and we're just going to highlight that, hit Control-C to copy, or you could right-click on it to copy. Excuse me. Come down here to Start, Search, type in CMD. If you're running Windows 7 or earlier, you can type in Start Run CMD to open up the command prompt. And we're going to go ahead and enter. Now, if you've just started watching my tutorial series, go ahead and type in Java C and press enter. And if you don't see a whole bunch of things scroll in front of there, then you have not installed the Java development kit, the JDK, properly at this point. So go ahead and review my video on installing the JDK, and then you can come back to this here. So I'm just going to come down here, type in CLS, clear the screen, type in CD space / CD is short for change directory, / tells it to go to the root. We're going to do MD, which is short for make directory, and then Java. I already have it, so we're going to go ahead and change it to the Java folder. Type make directory, and this particular one, I am going to call char primitive. And we'll go ahead and change to the char primitive folder. Notepad char primitive.java. Charprimitive.java is going to be the name of our source code file. You obviously have to always have the Java extension, is case sensitive. Let's go ahead and create that. Control V or right click to paste, either way. And what we've got here is, of course, we've got our class definition, opening, closing, curly braces. We've got our main method entry point here, and then we got our opening brace, closing brace for our code block in there. So the way we're going to declare this is we got a data type char, we got our variable name var a, we got our assignment operator equals, and then we've got our character literal here, followed by our semicolon, which terminates the statement. Okay. We're also going to declare and assign 2 other variables, var c and var t, and then we're simply going to use the print method, and with print with no ln, only just does not do a line feed after it prints it to the screen, so, or the console. So we're going to print C to the console, A to the console, T to the console. We should get cat spelled out, and then we'll send out a new line here. And then now what we've done down here is we're going to go ahead and declare and assign 3 more variables here. Char is the data type, variable name var_d, also known as the identifier, assignment operator, and then 68. So I'm going to go ahead and pull back up the website here real quick. If we scroll down to the Ascii chart, you can see 68 is a D, right? An uppercase D specifically. And 79 is an uppercase O. And G, 71 is an uppercase G. Okay, so we can do this here, and we'll go ahead and print that out to the console too as well. Let's go ahead and save this. Come back here, we'll type in CLS to clear the screen. Java C is the Java compiler. We're going to pass it the name of the Java source code file that we want to go ahead and compile. It's also known as a compilation unit there. And then we'll type in Java primitive. Java calls the Java runtime or the JVM Java Virtual Machine, and then we basically invoke the class name that we want to call, which is the char primitive class here. And let's go ahead and hit enter on that, and we get exactly what we expected, cat and dog. All right, excellent. Let's go ahead and pop back to the website here. Let's scroll up to our next exercise here. And the purpose of this one is to use a for loop to go ahead and display all the letters of the alphabet to the console there. Okay, so we're going to go ahead and save this here. Overwrite and save everything we currently got in there. So we've still got our char data type, same variable name here, and we are assigning it the string, the char literal of the uppercase A. Now I've also created another variable here called backspace, and we're assigning it 8. Okay. Now 8 is not printed on the ASCII printable characters down there. It's what's called a control code. So there's a whole bunch more ASCII codes than what I've got listed on my website there. But a control code, you can Google the whole ASCII chart and take a look at everything if you want to there. So we've got a basic for statement here. We've got our initialization, our identifier, then we've got our termination expression, and then our increment expression here. And we're going to go through 26 times, so 26 letters in the alphabet, and we're going to print var A, plus just a simple tack on a comma at the end of that, and then we're going to use our increment operator, plus, to go ahead and add 1 to var A, right? And I'm just going to pop back to the website here real quick, ASCII table. So what this will do, it will take us, change 65 to 66, and then it'll display that out there, a B, and so on and so forth, all the way through the whole entire alphabet. So let's go ahead and save this here. Let's clear our screen, compile that. And we get all of our letters of the alphabet, A through Z. And as you'll notice, there's no comma at the very end of that. And that's because we called this backspace at the very end and then just put a space in there. If I were to say, for example, just comment that out, save this, recompile it. And by the way, I'm using up and down arrow keys on the keyboard for shortcuts. That's how I'm doing that, if you're not familiar with that. And so you can see if we comment out that line, we just get in our ugly comma at the very end. So not only does this make it look better, but you also get to learn a little bit more about using the character literals and the primitive data char type. Oop. Forgot to compile it there. There we go. Boom. Okay, now it's pretty again. Okay. All right, I'm going to go ahead and close out of that. Close out of this. And you might want to review, if you're not familiar with all that stuff that I've done, you know, the binary stuff, the ASCII, and the Unicode. You might want to review this tutorial a few times if it's not quite exactly sticking yet. But that concludes this tutorial. Thanks for watching.